slope, and tables. Slope. We usually see it written as m equals. Okay, what does m equals? Well, the m could stand for a couple of things that might help us understand a few ways that we can interpret slope. Slope is how my line on my graph moves. It's what I am multiplying by in my equation. It's how my table moves. It might be what I'm multiplying in my table. So the word m, I could use a couple of words that stand for m that help us understand slope. There's an equation that we can use to help us with finding slope of tables, and that is the y2 minus y1 over x2 minus x1. Let's say we're given two ordered pairs. Let's say one of them is 1, 2, and another one is 2, 4. When we look at these ordered pairs, we have our x and our y. Here's our x, and here's our y. Okay, so we want to, now that we've, separated the x and the y, we want to figure out which one is first and which one's second. Well, this one is our first one. Here's our first one. And obviously the next one is going to be the second one. This is the one that's second. Okay, so that's what that little subscript is saying. It's just the first one's going to be subtracted from the second one. Okay, so let's go ahead and figure out what goes where. Let me get my black back. Okay, so x1, x2, but we're going to start here first. So x, my second ordered pair versus my first ordered pair. So we're going to go 2 minus 1, and then my y's, I have a 4 minus a 2. Okay, so what does that give me? What am I left with? Well, let's subtract and find out. So 4 minus 2 is 2, and 2 minus 1 is 1. Now I'm left with m equals 2 over 1. When I simplify that, what am I going to get? Just 2. 2 is my slope. But it also has the meaning of 2 over 1. Remember I said it's how my table moves, how my line moves, what's being multiplied in my equation. If we substituted this in my equation, y equals mx plus b, we would have y equals not m, but we're going to replace the 2 for the m, so 2x, and I didn't have a y-intercept because we multiplied and didn't have to add or subtract anything to get the following thing. Okay, so let's back up. Let me erase. Let's try another one. So here's my table. My x values go 2 to 4. My y values go 10 to 20. I'm going to do the same formula. I'll show you my formula down here. y2 minus y1 over x2 minus x1. The only difference is I'm going to use this table here. Okay, so I'm going to say 20 from 10, which really my table is going this way. Okay, but if I say how do I get from 10 to 20, you're going to say plus 10, aren't you? Well, that's the same thing I'm doing down in my equation because I'm subtracting in my head. I'm saying, well, 20 minus 10 is 10. And then what happens when we go up top? I'm going to ask the same question. This is how equations work. We ask how do we solve them, and in our head we are subtracting even though 2 plus 2 equals 4. We have to subtract the 2 from the 4, the 2 from the 4 to get 2. So when I plug in that 2 down at the bottom, now I have 10 over 2. So I get 5 over 1 when I simplify it, and that's how my table is moving. So if I wanted to keep going, I could keep going with this. So watch, I'm going to draw my line. I could keep going plus 10, which would give me 30, plus 2, which would give me 6. But watch, if I use this 5 over 1, guess what? All of a sudden now I can fill what goes in the end, what goes in between. So this space right here, couldn't there be a 5 right there? And that would be plus 1, wouldn't it? And then how would I get from 20? I wouldn't go all the way to 30, but I would add 5, which would give me 25. So somehow using our slope, we can fill in our missing tables. We can complete the tables. We can fill in, we can go on. So let me give you one more example that you can do by yourself. Okay, look at this table. So what I want you to do is I want you to tell me, what is my slope? I want to know how my y is going to move over how my x is going to move. You are more than welcome to use y2 minus y1 over x2 minus x1. Or you can look at how my table is moving from y to x to x. Okay? Pause the video, and then I want you to give it a shot. Okay. So let's see how you did. So I'm going to use the table on how my table moves first, and then we'll check it with our equation to make sure if you use the equation that you used it properly. So how am I going from a 3 to a 6? Well, that would be adding a 3. Well, that's easy enough. Okay. Well, how am I going from a 2 to a 4 on my x's? That would be adding a 2. Interesting. Okay. So when we're messing with our slope, we got to make sure our y is over our x, or we could think, if we can't remember y over x, rise over run. Okay? And if you're thinking of a hot air balloon, the hot air balloon rises, and we run on the ground. We physically can't run up, but that's how our slope works, rise over run. Okay? Okay, so I'm going to go up 3 on my y, and on my x's I'm moving over 2. Interesting. Am I allowed to have a fraction for a slope? Well, of course you are. Of course you are. I mean, it makes sense, money. Like, you can make $1.50 an hour. I mean, that would be, really low, but I mean, you can have $1.50. It could be $1.50 per book, or I don't know, but you can definitely have fractions. But we're going to keep it in fraction form. I'm not going to convert it to a mixed number or a decimal. I'm just going to keep it as 3 over 2, okay? Let's go ahead and plug it into our equation. We're always going to start with y equals for my linear functions, and we're going to use my 3 over 2, and my slope is always multiplied by my x. Okay, how'd you do? Good job.